Also, one of the great guidelines for tube selections was the one issued by Parker Corporation. In this guideline, Parker Corporation focus on sample temperature and pressure and its relation with sample tube material and wall thickness. First, Parker Corporation gives us some very important advice. We have to take care to use instrument fittings the same material as the tube material. Instrument fittings are designed to work on like materials. Stainless steel fittings should be used only with stainless steel tubing, aluminum fittings with aluminum tubing, etc. The practice of mixing materials is strongly discouraged. The only exception is brass fittings with copper tubing. But why is that? Dissimilar materials in contact may be susceptible to galvanic corrosion. Further, different materials have different levels of hardness, and can adversely affect the fitting's ability to seal on the tubing. Second, the most important consideration in the selection of suitable tubing for any application is the compatibility of the tubing material with the media to be contained. In this table, the guideline states what is the recommended tube material for certain applications and the recommended temperature range. For example, for high pressure, high temperature, generally corrosive media with temperature range, -255 degrees Celsius to 605 degrees Celsius, we use stainless steel. For oil, air, some specialty chemicals at lower temperature range, -29 degrees Celsius to 425 degrees Celsius, we can use carbon steel. For low temperature, low pressure water, oil, air at lower temperature range, -40 degrees Celsius to 205 degrees Celsius, we can use copper or aluminum material. Some alloys are also given here and used in some special application, such as Monel 400, Hastelloy C276, Carpenter 20, Inconel Alloy 600, titanium. For example, Monel 400 is recommended for sour gas applications while suited for marine and general chemical processing applications. Hastelloy C276 has excellent corrosion resistance to both oxidizing and reducing media, and excellent resistance to localized corrosion attack. Carpenter 20 applications requiring resistance to stress corrosion cracking in extreme conditions. Inconel Alloy 600 is recommended for high-temperature applications with generally corrosive media. Titanium is resistant to many natural environments such as seawater, body fluids, and salt solutions. The third point is operating pressure and its relation to tube size and wall thickness. The system operating pressure is an important factor in determining the size of tubing to be used. In general, high-pressure installations require strong materials such as steel or stainless steel. The following tables list the maximum suggested working pressure in psi of various tubing sizes. Note that ratings in gray not suitable for gas service. These is the same as the previous table but for carbon steel and aluminum. System temperature. Operating temperature is another factor in determining the proper tubing material. Copper and aluminum tubing are suitable for low-temperature media. Stainless steel and carbon steel tubing are suitable for higher temperature media. Special alloys such as Alloy 600 are recommended for extremely high temperatures. This table lists derating factors which should be applied to the working pressures listed before for elevated temperature conditions. Simply locate the correct factor and multiply this by the appropriate value from the previous tables. Let's take an example. Let us consider half an inch tube, 0.49 wall thickness, seamless 316 stainless steel tubing. From the table we can find its working pressure of 3,700 psi at room temperature. If the system were to operate at 800 degrees Fahrenheit 425 degrees Celsius, a factor of 80% or 0.80 should be applied. So the at temperature system pressure would be 3,700 psi multiplied by 0.80 equals 2,960 psi.